Have you ever wondered how we meet the world's growing energy needs without furthering endangering the environment? Or imagine a future where we could generate electricity without adding damaging greenhouse gases to the atmosphere? To get through each day, we need energy. Our cities are kept running, our homes are powered, and our cars are fueled. But due to our reliance on fossil fuels, carbon emissions have risen alarmingly, a factor in the catastrophic repercussions of climate change. Our need for energy is increasing at the same time as the global population. It's time to look at alternative energy sources that give us a sustainable future. Is nuclear energy the answer that we've been waiting for, even though it's long been contentious? We will discuss the benefits of nuclear energy and how it can save the planet in this video. It may be the solution to our energy dilemma. Nuclear fusion has been a long-awaited solution to the world's energy issues, but it's never fully arrived. It has always been 20 years distant. But suppose it did. What if we created a nuclear fusion power plant that was affordable and revolutionized the world as we know it? This video will examine nuclear fusion's potential, background, and workings, the difficulties we encounter, and the possible advantages of this groundbreaking technology will also be discussed. Nuclear fusion is the process of joining two or more minor elements to create new elements, which results in a massive release of energy. The tricky part is getting through the electromagnetic repulsion that pulls the atoms apart. To achieve this, we generate a plasma, a cloud of charged ions that a magnetic field can control. We can keep the ions from striking the fusion generator's walls and gradually increase its temperature by enclosing the plasma within a magnetic field. As a result, the ions accelerate and eventually reach a point where their kinetic energy is so great that it overcomes electromagnetic repulsion, allowing them to collide. An enormous amount of energy is released during this impact and may be used too. The first generators fired up in the 1950s in both the USA and the USSR, signaling the start of nuclear fusion experiments that have been going on since the beginning of the Cold War. While the Americans utilized a somewhat different strategy, the Stellarator, the Soviet Union attacked the issue with a tokamak design. Both approaches employ giant superconducting magnets to provide magnetic field confinement, using different techniques to induce fusion. The USSR's 1968 disclosure of information on the tokamak design, which demonstrated a significant increase in energy efficiency, led to the tokamak becoming the most widely used design today. Deuterium and tritium were the fuels employed by both designs. The likelihood of these fuels producing helium-4 and emitting massive radiation is relatively high. The same reactants used considerably influence the quantity of energy needed to start the reaction and the energy content of the result. Since ordinary hydrogen has one proton in its nucleus and one electron in orbit, fusion may be carried out with it. Nevertheless, the process only produces a small quantity of energy. Unlike deuterium, which only possesses a proton, an electron, and a neutron, tritium has a proton, an electron, and two neutrons. Several variables influence the use of this combination. First, it offers us the highest possibility of getting us the desired result. The possibility of the desired reaction, the confluence of the deuterium generating processes, is lower. A cost-effective nuclear fusion power plant would fundamentally alter society if we, as a civilization, were to succeed in developing one. Every nation can use this technology thanks to clean, safe fuels. As we compete to control energy sources, nations will be energy independent, avoiding one of the leading causes of hostilities worldwide. Every sci-fi utopian society is built around accessible, affordable, and abundant energy. We could electrify sectors of the economy that currently depend on fossil fuels, such as the steel industry, and it would address our climate change problems. Additionally, we could develop brand new businesses like water desalination that energy prices have hampered. Concerning mass basis, nuclear fission is vastly outperformed in energy output by deuterium-tritium fusion. As a second step, we must determine how to contain the plasma more effectively, with temperatures exceeding tens of millions of degrees Celsius. The plasma is scorching, which is a concern. This implies that the plasma will quickly melt whatever material we employ to confine it, rendering sustained fusion impossible. As previously noted, magnetic fields might be used as a solution to confine the plasma. The giant superconducting magnets required to provide the magnetic fields necessary to contain the plasma are mighty. Because liquid helium must be used to cool these magnets, the system becomes more expensive and complicated. Another option is to employ inertial confinement, which involves directing intense laser beams at a fuel pellet containing deuterium and tritium. Fuel pellets are heated by lasers, which induces fusion in them. Although this technique has been influential in the lab, it still needs to be determined if it can be scaled up to create appropriate amounts of energy. However difficult it may be, fusion research is moving forward. The International Thermonuclear Experimental Reactor, the ITER, which will produce the first sustained fusion reaction in the middle of the 2020s, is one of several potential experimental fusion reactors currently being built. One of history's most significant scientific endeavors, the ITER project involves a partnership between 35 nations. If ITER is successful, it may open the door to industrial fusion power plants. ITER isn't the only private organization working on fusion research. Others include Helion Energy, which employs a novel fusion strategy that could be more successful and affordable than conventional designs. In conclusion, nuclear fusion is not impractical, even if it's long been a pipe dream. Fusion power might revolutionize civilization if we can make it affordable while supplying enough clean, secure, and reliable energy for every nation. The promise of fusion energy is encouraging, even though many significant technological obstacles remain to be solved. Finally, compared to other energy sources, nuclear energy offers significant benefits. It can satisfy the world's rising energy needs without causing environmental damage. It is a clean, efficient, safe, and dependable energy source. The advantages of nuclear energy outweighs the hazards despite its difficulties. The moment has come to accept nuclear energy as a vital part of a sustainable future.